Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and in today's short application exercise, we'll program and test a PLC-based reversing motor starter with plugging action. We'll demonstrate the behavior during normal operation and its response to emergency stops and overloads. This lecture is intended to be a quick bonus round extension of the PLC-based reversing motor starter featuring the TECO SG2 PLR lecture, available at the Big Bad Tech channel. If you haven't watched this lecture yet or only dimly recall its contents, please take the time to do so now. Additionally, it is presumed the viewer has some experience with reversing motor starters featuring plugging action as implemented using traditional hardwire relay-based ladder logic. If you wish to review reversing motor starters featuring plugging action as implemented using traditional hardwire relay-based ladder logic, you are encouraged to check out the Plugging Circuits lecture, available at the Big Bad Tech channel. You will recall in the aforementioned PLC-based reversing motor starter featuring the TECO SG2 PLR lecture, we programmed and tested a PLC-based reversing motor starter that made use of not only mechanically interlocked forward and reversing contactors that prevented simultaneous movement of both contactors, but also software-generated electrical interlocks that prevent the coils of the forward and reversing contactors from simultaneously being energized. This resulted in a reversing motor starter that, once placed in a particular operational mode, would ignore attempts to place it into the opposite mode until an operator first stopped the system. Here's the program we used for this previous implementation. Different types of reversing motor starters exist that exhibit plugging action, where plugging is defined as the instantaneous reversal of the rotating magnetic field bypassing a de-energized stopped intermediary. The counter-torque produced by the plugging action will rapidly decelerate a moving rotor and accelerate it in the opposite direction. The plugging action is characterized by massive inrush current and a dramatic torque reversal, so it may not be suitable for all applications. This being said, I really like plugging circuits, and it'd be foolish not to check one out, given it takes only minimal effort on our part to do so. PLCs, among their many virtues, are reprogrammable flexible devices that make modification of a system possible without the time-consuming necessity of physically rewiring it. Due to the reprogrammable nature of our PLC-based system, the only modification necessary to include plugging action is replacement of the software-generated electrical interlock on rungs 1 and 3, with software-generated push-button interlocks. You know, rung 1 has been modified to include a software-generated brake instruction examining input I4, the normally open momentary contact yellow reversing push-button, in series with output Q1, the forward contactor coil. Similarly, rung 3 includes a software-generated brake instruction examining input I3, the normally open momentary contact green forward push-button, in series with output Q2, the reversing contactor coil. These are the software-generated push-button interlocks characteristic of a reversing motor starter featuring plugging action. In summary, when forward mode is asserted via the green push-button on input 3, the software-generated push-button interlock instruction on rung 3 deselects reverse. And similarly, when reverse is asserted via the yellow push-button on input 4, the software-generated push-button interlock instruction on rung 1 deselects forward. When placed in a particular operational mode, selection of the opposite mode toggles the system, bypassing the stopped intermediary state. The plugging action rapidly decelerates the moving rotor and accelerates it in the opposite direction. You'll note neither the emergency stop, the overload, nor the mechanically interlocked contactors make an appearance in the program. However, these devices are readily apparent in the hardwired schematic. Wired in this fashion, the emergency stop and overload serve to override the PLC program in the event of an emergency stop or overload event, and the mechanically interlocked contactors prevent simultaneous physical closure of the forward and reversing contactors.